Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good morning to all of you, three amethysts.
Waalaikumsalam,
So,
teacher.
today we will continue our lesson by discussing about chapter 4.2. After 2 weeks ago, we have started to discuss about the reactivity of metal 4.1 about the minerals itself. So the variety of minerals that we have discussed 2 weeks ago is very important in our daily life, because from there we can get lots of metals and also non-metals. So exactly most of the metals that we get are in the form of elements. For example, gold, silver, and then metal also mostly come from the natural compound in the rock or in the ore itself. So all these metals in the form of natural compound have to be extracted from this rock or ore, and this will be discussed in 4.3, in which we will discuss how this metal being extracted from their rock. Okay, now 4.2. We will look into these metals. So when these metals that we get from their ore or their rock, so in which maybe all these metal, whether in the form of elements or natural compound, in the compound, so we take only the metal itself, and then we separate them from the compound itself. So most of the metals right now we can separate from their natural compound. Okay, now we will look what is the reactivity of this metal towards other elements. For example, what we are trying to discuss today is the reaction of metals towards oxygen gas. Okay, so exactly these metals have been studied by all the scientists around the world about their reactivity, about their reaction towards all other elements. For example, these metals, they can react. Metal, they can react with oxygen to form metal oxide. Okay, metal also can react with other elements, mostly non-metals. So oxygen is one type of non-metals. For example, other elements is chlorine. So when metals react with chlorine, it will form metal chloride. So what the things that I wrote just now, this is what we call as a chemical equation in words. Chemical equation in words. This one is a chemical equation that represent the reaction between the substance. Okay, metal also can react with, for example, not only element, also they can react with other compound. For example, metal oxide. Metal oxide. So, and so many reaction can be discussed based on the reaction of metals. Okay, so for this syllabus of Form 3 for reactivities of metals, so we will discuss about the reaction of metals and oxygen. So when metals react with oxygen gas, so it will form a new compound. So this new compound, we call it as a metal oxide. Metal, so depend on the type of metal oxide. And this metal oxide is a new compound that is consists of metal and oxygen. So for example, if we take magnesium, so this magnesium, when burned with oxygen, so it will form a new compound. We call it as a magnesium oxide. Okay, so this is a new compound. We call it a magnesium oxide. And second example given here, iron. So iron, when react with oxygen, so it will form iron, new compound, we call it as a iron oxide. Okay, so this is example based on the representation by chemical equation on how metals react with oxygen gas. Okay, so what we want to learn today is we want to compare. For example, two metals here, iron and magnesium. So what is the comparison of their reactivity towards oxygen? Is it that magnesium is more reactive? We want to know whether magnesium is more reactive, lebih cergas, lebih reaktif compared to iron. Is it iron is less reactive? Adakah iron kurang reaktif, bertindak balas dengan oksigen, or vice versa. So all the metals exactly have been studied, investigated by scientists to determine which metal that have higher reactivity towards oxygen and which metal have low reactivity towards oxygen. So all these metals, based on their reaction towards oxygen gas, have been arranged, and we call this arrangement as the reactivity series of metals. So this reactivity series, okay, this reactivity series of elements, reactivity series of metal is exactly the arrangement of metals based on their reaction towards oxygen gas. Okay, towards their oxygen gas. So from here, based on their reaction, towards oxygen gas. So we know which metal is more vigorous, more reactive, which metal is less vigorous or less reactive. Yeah? So from this reactivity series of metal, yeah, so which one? So if you look back at the previous arrangement, this one, so this one, so this one, is the what we call as a reactivity series of metal. So start from the potassium. Start from potassium. Second is sodium. Next is calcium, magnesium, aluminium, carbon, zinc, hydrogen, iron, tin, lead, copper, mercury, silver, and gold. So based on this arrangement, potassium become the most reactive elements compared to the other element. So the second reactive metal is sodium, the third reactive metal is calcium, and so on. So we can see from here, gold become the less reactive, less reactive metal. Okay, you can see from this arrow, show that when we go upwards, so the reactivity of metal toward oxygen increases. So potassium will become most reactive, yang paling cergas sekali bertindak balas. Gold is the less reactive metals compare. So in this reactivity series of metal, we also include carbon and hydrogen, even though this carbon and hydrogen is a non-metal. So why did we put these two non-metal inside the series of metals, reactivity series of metal? Because this carbon and hydrogen also have their own function to react with oxygen gas. So when they react with oxygen gas, so they have their own degree of reactivities. And then when this carbon react with the oxide of this metal, so they have their own reactivity. That's why we put these two non-metals inside the reactivity series of metals, because exactly carbon and hydrogen, even though this is a non-metal elements, but we use it more often in the industries, in the right nowadays industries. They are very important to our daily life. So this is the reactivity series of metal that you have to remember. So please remember this arrangement. Please remember this reactivity series of element. So because this element will be used in the SPM level in chemistry. So very important for you starting from now to memorize this name of metals that form the arrangement in the reactivity series of metals. Okay, so now we will look how this reactivity series of metal is arranged and how the activity or the reaction of this metal is conducted towards oxygen. So we want to know what is exactly happen during this reaction. Yeah. Okay, so how to construct the reactivity series of metal? Yeah. Okay, so based on this textbook, okay, you can read on your own this one. So is the vigor of reaction of different metals such as magnesium and iron with oxygen the same or different? So I have explained to you. For example, given here in a vigorous reaction between more reactive metals such as magnesium with oxygen, so what will happen is a bright flame is observed as shown in the photograph 4.5. So when more reactive metal, for example magnesium, react with oxygen, so the observation that we can look is a bright flame occur. So the bright flame become our criteria, of observation. So this criteria make a conclusion to us, can be concluded that magnesium is very vigor, very reactive when react with oxygen. Compare with, for example, in a less vigorous reaction, dalam tindak balas yang kurang cergas, for example, iron, less reactive metal, for example, iron. So when iron react with oxygen gas, so what will happen? We can observe only a slow change or a glow. A glow mean in BM bara. Okay, we can only observe baraan sahaja, or a slow change in color. So we can see from this reaction, the reaction is very slow and only produce a glow of reaction. So based on this criteria, what exactly happened during the reaction, so we can know that whether the metal is reactive or less reactive. So based on that criteria, based on the observation that we look into the reaction of metals with oxygen gas, so we can construct the reactivity series of metals as we have discussed before. Okay, so same thing. So this is the reactivity series of metal based on the reaction towards oxygen gas. So now we want to look how this experiment, how this activity is being conducted. So we look into the activity 4.3 in your textbook, page 130, 130, muka surat 130. So this aim, the objective of this activity 4.3, okay, so we want to study the reaction of heating metals, to study the reaction of metals such as magnesium, aluminium, zinc, iron, and lead. So here given 1, 2, 3, 4, and 5 different type of metals. We want to compare their vigorosity towards oxygen gas. So we want to observe their reaction. So what is the materials and apparatus? Okay, we are given this one. Please remember this name, chemical name for this substance, potassium manganate 7 crystals in the form of solid crystal. And then we are given metals in the form of powder, magnesium powder, aluminium powder, zinc powder, iron powder, lead powder. So all the metals in the form of powder, and also glass wool. That are the materials used. Okay, so apparatus used are boiling tube, retort stand with clamp, porcelain plate, spatula, and Bunsen burner. Okay, so the safety precaution. So you have to know what is the safety precaution that are applied for every activity or experiment. So you have to know. Okay, the statement given here: glass wool are very dangerous because this wool contain glass powder. So use forceps to handle them, and then make sure you wear safety glasses and cover your mouth and nose when handling glass wool. Kapas kaca, glass wool. So do not allow glass wool to enter your body. Wash your hand after handling glass wool. Okay, second is potassium manganate crystal and metal powder can explode if mixed during heating. So this is very important during conducting this experiment. So if potassium manganate and metal powder mix during the heating process, so explosion can occur. So make sure both of these materials are always kept apart. Mesti diasingkan, tidak boleh dicampurkan. So we look into what is the procedure of this experiment. Okay, so this is the setup apparatus in conducting this experiment. Okay, first of all, we have this boiling tube. We have a boiling tube here. This is a boiling tube. Okay, clamp with the retort stand. Okay, like this. This is a retort stand. Retort stand. Retort stand. And then this is the clamp. Pengapit. So this clamp will stick this one boiling tube, glass boiling tube made up of glass. Okay, so what we are going to do is, okay, first of all, we have to put inside potassium manganate crystal. So this potassium manganate crystal, the color is exactly purple. So the color of this potassium manganate 7 crystal is purple in color. Okay, so we put several here, put one spatula inside the boiling tube or dry boiling tube. Make sure that it is dry. And then after that, we put this one, glass wool. Okay. And then the third materials located here, we put metal powder in the porcelain plate. So metal powder is put here, glass wool, and potassium manganate. So you can see this glass wool exactly want to separate the potassium manganate and also metal powder. So the function of glass wool itself want to separate, untuk mengasingkan, to prevent the mixing of potassium manganate 7 and metal powder, as we have discussed before that if the metal and potassium manganate mixed together during the process, during the heating process, so it will explode. So we want to prevent from this to happen. Yeah, so we arrange the metal powder and potassium manganate like this, and between them is a glass wool. Okay, so what we are going to do is, okay, why we use potassium manganate? Yeah, why we use potassium manganate? So where is the oxygen that we supposed to react with the metal powder? Exactly this experiment, we want to look into the reaction between metal and oxygen gas. So where we can get oxygen gas? Okay, there are two sources of oxygen gas. Yeah, one we can get from the air. In which if we want to react metal with oxygen, so we just burn it in the open space. And the second one, we can get oxygen gas from the decomposition of potassium manganate. So the function of potassium manganate crystal here, the main function here, so you have to know this one, to provide oxygen gas. That is the function of potassium manganate in this experiment. So when we heat potassium manganate here, what will happen is this potassium manganate crystal will be decomposed, and then when the decomposition occur, so it will produce oxygen gas. Okay, so oxygen gas will be released as a product, as one of the product of decomposition of potassium manganate crystal. So I repeat again, when we heat potassium manganate, so potassium manganate will decompose to become oxygen gas as one of the product. So this oxygen gas will passing through glass wool, and then, so what will happen? So we have lot of oxygen gas inside the boiling tube. So what will happen? We will heat the metal so strongly. So what will happen is, so the metal when heated, so it will react with the oxygen gas. So when they react, so the observation can be looked. So we can see, we can observe what exactly happened during the reaction between metal and oxygen. So this is the summary of this experiment on how we can observe the vigorosity of metals toward oxygen gas. So number 1, number 2, number 3 is the procedure that I have told you. So observe the vigor of the reaction. So record your observation in the table. Take a video recording or photograph during the reaction. And then, so you can change the metal here. We can start from magnesium, and then after that, aluminium, and then zinc, iron, and then lead. So we arrange this observation using the table given here. So all the metals, and then what is the observation that we have observed. So from here we know. So this table, metal burns very quickly and brightly. Okay, which one is which metal burns very quickly and brightly? So based on this table, an observation. So we can put, okay, magnesium burns very quickly and brightly. So next, the observation, we can see metal burns quickly and brightly. So this one, very quickly and brightly. So what the metal that burns quickly and brightly? That is aluminium. Yeah? Metal that burns slowly, zinc. Metal glows brightly, this one iron. And metal glows dimly. Yeah? Berbara dengan dimly, malap lah. Berbara dengan malap. So metals glow dimly during reaction with oxygen is lead. So this is the statement of observation that you must use during explain what exactly happened during the reaction between all these metals with oxygen. So you have to use this statement, this sentence. So in order to explain about the vigor of the reaction of metals. Metals burn very quickly and brightly. Metal burns quickly and brightly. Metal burns slowly. Metal glows brightly. Metal glows dimly. So please use this statement in order to explain about the vigor of the reaction. Okay, so based on that, observation, so we have to answer several questions given in this textbook. Okay, so number 1 here, complete the word equation for the reaction of each metal with oxygen. So this word equation, so A, B, C, D, E, so this is a equation. This is equation in the form of word. I have told you before. So this equation represent the reaction between substance and then the product. So this is the substance. Okay, magnesium react with oxygen. So this is a substance. So what is the product of this reaction? So I have told you before. So the product is based on the different type of metal. So here we can write the name of product is a compound, new compound. So now magnesium is an element, oxygen is an element, metal elements, and non-metal elements. So when they react together, so it will form a new compound. We call it as a magnesium oxide. So this is how to write. Magnesium oxide, not magnesium oxygen. So the name given, chemical name is like this. At the end of the non-metal, we put IDE, not GEN. So from oxygen will become oxide. We replace with IDE, oxide. All the non-metal is like that. Okay, aluminium and oxygen. So will become new compound. We call it as a aluminium oxide. Okay, zinc react with oxygen will become zinc oxide. Okay. Iron with oxygen will become iron oxide. Lead with oxygen will become lead oxide. Okay, so this is how to write word equation, persamaan dalam perkataan. Chemical word equation. Okay, I want to look into the attendance first. Then 26. Alia, Amira. Okay. Ahmad. Muhammad Zarfan, Nur Ain, Nur Aisyah, Nur Alia, Nur Duratul Hakimah, Nur Huda. Okay, after this, I want you to open your video to show that you exactly attend this class. I don't want you to cheat. Just put on your Google Meet and then you sleep maybe or go to the other place. Nuri, Putri Dayana, Putri Aris, Renisha. Kenapa sikit satu ni? Okay, 26 of you. So 26 of you. Okay. So the next question about this one. State the relationship between the vigor of the reaction and the reactivity of the metals toward oxygen. Number 3, based on the result from this activity, complete the following sequence of metals according to their decreasing reactivity towards oxygen. So based on this vigorosity of reaction towards oxygen, so we can arrange the sequence of metals according to their decreasing reactivity. So from the more reactive, more vigorous, into the less vigorous reaction. So from here we can say that magnesium, with the comparison between 5 metals, magnesium is the most reactive metals. The second most reactive metal is aluminium.
Wait, asal cikgu left meeting?
Komputer crash.
Tak payah buka kamera.
Oh, okay.